This video is going to talk about how to complete double displacement reactions. And double displacement reactions are a common reaction that takes place in chemistry. Usually people do them when they're looking for a solid, two aqueous solutions reacting together to form a solid, or to find out if a solid would form. They always follow this same pattern where there's typically a cation and an anion, so something positively charged and something negatively charged, reacting with something positive and negative, and they switch. So the positive ion from this compound goes with the negative ion in this compound, and we always write positive and then negative, and the same thing for the other. The positive ion of this goes to the negative ion. So double displacement, it's basically swapping. Now, these are not difficult as long as they have all the same charges. So if this was +1 and -1, +1 and -1, that's all you have to do is swap the anions and cations. If there are ions involved that have different charges, that's where it becomes a little more difficult. Okay? And I'm going to give you an example. So you need to know the charges of these ions in order for this to work properly. So in this case, I've memorized that nitrate is a -1 charge, so I'm going to write it above that. And now, if there are two negative ones, that means the lead must be a +2. Okay? Now, sodium chloride, I can look directly on the periodic table and figure out their charges. Sodium is +1 and chloride is -1. Now, remember, ionic compounds as written are neutral. And so you'll notice there are two of these negative ions for every one of these positive ions. So when we switch these, we have to take that into consideration. So, simple set of rules. 1, swap single ions. 2, make correct ionic compounds. And then 3, balance the reaction. So, first thing I'm going to do is I'm going to swap single ions. What that means is I'm going to ignore this 2 in this case. So I'm going to take the Pb, which I'm going to put its charge up here, and I'm going to remember, I'm going to take I take the cation from this compound and the anion from this compound. So I'm going to write these, just swapping single ions. Now this isn't a correct ionic compound yet, but I'll make it a correct ionic compound. And then plus, I'm going to take the cation from this side with the anion of the other one. And I'm just taking one of them. Now, the reason we do this is so that we don't bring this 2 automatically over to this side. Okay, so we're swapped our single ions. Now to make correct ionic compounds, what we have to do is we have to take into account these charges. So +2 and -1 means that I need 2 of these to make this a correct ionic compound. +1 and -1, that's neutral, so I don't have to do anything. That is a correct ionic compound. So I have this overall correct ionic compounds, but it isn't balanced because when I put a 2 here, I only had 1 on this side. And when I only took 1 of these nitrates, my equation isn't balanced. So in order to balance this, I have to say, okay, I have 2 chlorines over here. That means I can't change and put a 2 here. It would make this an incorrect ionic compound. So I'm going to bring that out as a coefficient. Okay? So when you balance a reaction, remember you change coefficients. You do not change subscripts because that would make them incorrect ionic compounds. So I have 2 chlorines now. Now I have 2 sodiums, so I'm going to need a 2 in front of here. And that's great because I had 2 nitrates here. Now I have 2 nitrates, but they're just paired up differently. So that is balancing a simple double displacement equation where you have to go back and actually balance the overall reaction.